So hi everyone, I'm Kevin Bowman. I've been developing messaging support for quite some time, and we've gotten a lot of calls for RabbitMQ support and AMQP in general. So this is kind of our first pass on the test side. First question is, what is RabbitMQ? It's a messaging provider like IBM MQ. A lot of providers will use MQ in their name just to confuse you, but this is completely different from IBM MQ. It's an implementation of a kind of a standard messaging protocol called AMQP, which stands for Advanced Message Queuing Protocol. And if you look, you can see a little bit of information on its website. If you go under Docs, Protocol Documentation, Compatibility, you can see the actual versions of AMQP that it supports. And you can also kind of see how it's interoperable with different AMQP providers like Apache Cupid and OpenAMQ. There are some caveats in here. The basic takeaway is that we can only really guarantee that our RabbitMQ support is compatible with RabbitMQ. You may be able to use it against other AMQP providers, but you might fall under some of the caveats they list on this site, so it's not something that we can guarantee. All right, so how do you get started using RabbitMQ? So there's an installation page on here. You can download the zip containing the Java client. I already have that here. It contains a bunch of files, but the only two that you really need are the commons.io jar and the RabbitMQ client jar. And you can take these two files and just copy them right into your Lisa home directory hot deploy. And because this is still an experimental status, you have to either create or edit a local.properties and add the lisa.experimental equals true line to enable this stuff. Once those two things are done, you can start or restart Workstation. You should be good to go. So let's take a look at let me start a blank project. And let's take a look at the new RabbitMQ assets. So the first one we're going to make is a connection, which is fairly self-explanatory. I'm currently running a RabbitMQ server locally. It's usually you run it on the command line. If you're on Linux or Mac, there's a service I think you can get with Windows that will keep it running in the background. And another thing that I've done is I've written the same. If you're familiar with my other videos on JMS and IBMMQ, there's a simple request response application that I usually use to test that, and I've written the same application for RabbitMQ. So I'm going to be using that during this demo to show off some of the different features. But first I need a connection. So the default port's filled in for you, and if you just install a RabbitMQ server from scratch, then it's going to have a default username and password, which is guest for the password. And you can test that to make sure that it works. Okay, I have a successful connection. Next thing I'm going to do is create a queue. This is going to be my request queue. We're going to talk about Exchange and routing key later, but for now I'm just going to select the RabbitMQ connection and test it out to make sure I can access that queue. Okay, and now I'm going to just duplicate that and make another one that's a response queue and test that out. So I'm getting an error. The response queue doesn't exist right now. So with RabbitMQ, basically queues are created on the fly for the most part. There's not a whole lot of administrative creation of queues. So what I can do to enable this behavior in Lisa is enable the pro mode, and I had to check the declare queue box, which basically just tells us to use the underlying API that creates the queue as opposed to just checking to make sure it exists. So if we run that, and now we can successfully get an instance of that queue. It's created this response queue on the RabbitMQ server. And you can run this as many times as you want with that checkbox checked. It doesn't do anything if it's already, the declare queue checkbox doesn't have any effect if it's already created. So now I have enough to create a step. I'm going to create a new test case. There's a new RabbitMQ step, then receive step. Oops. Look at the simple view for now. If you've seen the JMS and MQ native steps, then this should look very familiar. It's the same exact setup. You have the send side on the left, and I select my request queue, and the receive side on the right. I'm going to select my response queue, and I'm going to paste in a request. And try it out. And I received a response back, and I can check my service, see that it did indeed process a request. So that's the basics right there. That's from 0 to getting something working. So let's talk about some other stuff that we can do. In addition to just a regular static queue with a name, you can use a temporary queue. And the way RabbitMQ works, I get the feeling that for response queues, temporary queues are kind of the standard operating procedure. And we'll see why in a minute. But I'm guessing for the most part, you're going to see people using temp queues as a response queue, at least for the type of services that we're used to dealing with, the request response style services. If you're talking to a RabbitMQ person and you're trying to explain the type of services they can only deal with the request and response, most of the documentation I see with RabbitMQ calls these RPC style services, or remote procedure call. So there might be some good terminology to know if you're talking to some RabbitMQ people. Anyway, the temp queue, I just have to create a what channel. Again, we'll talk about exchange and non-queue later. And I'll run this again, and it should work just the same. I just got a second transaction through. So, and the reason this is working is I can look in the request, and just like JMS and MQ, there's a reply to field in the RabbitMQ message that can tell you what queue to send the reply to, what queue to send the response to. And this is like the generated name for our temporary queue. However, this is where RabbitMQ starts to go off the rails as far as being similar to JMS and IBM-MQ. Because while the AMQP spec defines a reply to field, it doesn't really specify what goes in it or how it's used. It's just a text field, and application developers can technically put whatever they want in there and use it however they like. There are a bunch of message properties that are like this. Basically, the name is defined in the spec, but no semantics. The reply to is one of them, and this presents kind of a problem for us. So if we dig into some of the advanced features here, you can see that there's actually two different reply to fields that show up everywhere. One of them is for selecting a queue. So by default, we're filling in the reply to field with the name of the received queue, which is why this previous transaction worked out of the box, is because we're automatically filling in the reply to field with the name of that temp queue that we created, and the service knows to respond to that, using that reply to field. But it doesn't have to work that way. You can put whatever string you want in there, which is why there's a second reply to field called a reply to key. So you can technically put whatever you want in there. And there might be applications out there that use this in a way different than just queue names. So the second place where this kind of starts to be a lot different from JMS and MQ is with exchanges. I've been kind of glossing over something until now, which is that you can't actually publish a message to a queue in RabbitMQ and in AMQP in general. You have to publish to something called an exchange, and that routes the message to its destination queue. Consumers can still receive stuff directly from a queue, but on the send side, you have to go through an exchange. And we've been able to work around this up until now in this demo because there's something called a default exchange in RabbitMQ, which is the exchange with a blank name. Every exchange has a name, and the default exchange is the one with a blank name. Basically, how exchanges work is a consumer has to create this temp queue or open its static response, its static receiving queue. and then it does something called a binding. It binds this queue to an exchange using some kind of routing information. Usually this routing information is a routing key, and you can see this in the queue asset. And you can also see a bind tag to say it should bind to this queue to an exchange using its routing key. And the way I tell it the exchange to bind it to is by creating an exchange asset. There are a couple of different types of exchange assets, and we'll go over 3 out of these. Fan out, it doesn't really apply to most of our cases, so I won't touch on that too much. But the other ones, direct, topic, and headers, we'll definitely go through. And on the send side, so that's how a consumer binds its queue to an exchange, and on the send side, it's the same kind of asset. So there's a routing queue on the send side, and the behavior is different between whether you're using this asset on the send side or the receive side. So basically the sequence of events is on the receive side, a consumer on a queue will take its queue and bind it to an exchange using some routing key or other information. And then on the send side, the producer will send a message to that exchange using a routing key or some other piece of information that matches what was bound on the receive side, and the exchange takes care of routing the message to the right queue. Exchanges may route to multiple queues. If you have more than one queue bound with the same routing key or the similar routing information, it can route to more than one queue the same message. Or it could route, if there are no exchanges or no queues bound to the exchange with the matching routing information, it may send to 0 queue. So it works kind of like a topic in that way, like if you're familiar with how JMS topics work. So I mentioned the default exchange, and that's what we've been using up until now. So by default, every queue that you create in RabbitMQ is automatically bound to the default exchange, and its routing key that you use to send is just the name of the queue. So it's as close as you can get an AMQP to sending a message directly to a queue with using the default exchange. And now I'm going to talk, so the other kinds of exchanges I'm going to talk about along with the correlation schemes. So for doing request response correlation, I have built 4 correlation schemes. 3 of them are basically related directly to one of 3 exchange types: direct, topic, and headers. And there's a 4th one, the payload-based exchange, we'll get to at the end. So with a direct exchange, the routing key doesn't necessarily have to be the name of the queue. It could just be any string. So the consumer binds their queue to the exchange using some string as a routing key, and the publisher sends a message to that exchange using the exact same routing key. And the exchange doesn't match up and routes the message to the right queue. So let me restart my service. So it's using a direct exchange. And I have my courses. In general, you shouldn't need to mess with the advanced diagrams. You can just select the RabbitMQ directly, and it should work most of the time. So that response came back. I can see the reply to field on the request. Instead of having a queue name, just has a string that was generated by DevTest. If I wanted to do all of this manually without using a correlation scheme, then I would have to come in here. Actually, one other thing I want to show before we do that. So I didn't actually create an exchange for this. So there's a default direct exchange, which is different from the default exchange. And it actually has a name. It's called AMQ.direct. And the correlation scheme, the direct correlation scheme, is smart enough that if you don't actually have an exchange selected on your response queue, it'll use the default direct exchange. But if I wanted to use a different exchange, then I would have to go into my receive queue, edit it, and add an exchange. So the direct type, give it a name. And if I wanted to set everything up, and if I just wanted to use this exchange but let the correlation scheme do its job, then that's all I would need to do. But if I wanted to not use the correlation scheme at all and set everything up manually, then I would have to create this custom exchange asset and then generate a routing key myself and check the bind argument to make sure that it's bound the queue to that exchange using that routing key. But if I'm using the direct correlation scheme, then it sets all that up for me automatically. The next one I have here is topic, and topic works basically the same as direct. It's a little bit more sophisticated in terms of it can actually have some kind of matching that's not an exact match going on between the consumer's bind routing key and the publisher's send routing key. But for our purposes, for request response RPC style services, there's no difference. We're still using an exact match, so it works exactly the same as direct. It's just on a different exchange type. It's basically just a renamed version of direct to avoid any confusion, but it works exactly the same as direct. And the third exchange type is headers. This is one that does not use a routing key. So the headers exchange is similar to how a JMS selector query works, which is you can put a custom property in the message that we send out. Call it a CID, and then whatever generated string you want in there. And then what happens is you have to, if you were to set all this up manually, you would have to create a headers exchange asset, and you would have to bind the queue to that headers exchange. You have to, instead of specifying a routing key, you'd have to specify some bind argument, where you would say like, and then whatever string you entered before that has to match up. But using the headers correlation scheme, it sets all that up for you, and it can also use, there's also a default headers exchange, just like there's a default direct exchange. So the only thing I have to enter for this correlation scheme is the name of the property that I use on the request to store whatever generated ID I want. I can also, if there's a different property that's used on the response, I can put that here. I can leave that blank to use the same property on both the request and response. And that's what I'm going to do here. And I'm going to restart my service so it's using headers. Show this to you real quick. Okay, so the request, I can see I have a custom property. Is automatically added by the correlation scheme. I didn't have to put it in here or anything. And on the response, I should be able to see the same custom property echoed by the service. And I can see it selecting the default headers exchange. So as far as exchange types, that's all we really care about for our usual request response model. There's also, I mentioned before, there's also fan out. And this isn't really useful for a request. Basically, all fan out does is anything, it doesn't even use the routing keys. Anything down to a fan out exchange receives every message sent to that exchange. It's a big topic with no filter. So it's not really useful from a correlation standpoint. So there's no correlation scheme corresponding to this exchange type. The last correlation scheme is payload, which is, if you're familiar with the JMS and the MQ native steps, this is pulling that correlation ID out of the payload itself. So I actually set this up to use XPath and request ID. I just have to go into my request. Yep, I have to add a space for that. Okay, I'm going to restart my service again to use this kind of correlation. Now, if I try this out again, I can see that my request as a generated string put there in the ID field in the XML, and the response has the same thing. And all the filtering and making sure I receive the right response with that ID is done for me in the background. So I've tried to cover kind of the basics for each of the exchange types that we care about with correlation schemes. But again, because of the ambiguity with the way a lot of the fields are declared in the AMQP spec, we can't cover every possible scenario, which is why we have all these bells and whistles that you see in the queue and the exchange. So you can, if you run into something that isn't supported by those, you should be able to set something up. And if we manually, and if we see enough of it, we may want to start adding more correlation schemes. So you can see another. So there are some quote unquote standard message properties in AMQ, but again, things like correlation ID, message ID, the names are there in the AMQP spec, but there's no semantics or required behavior. It's another thing that the application developers may or may not use however they see fit. So it's not something we can really depend on.